Within the new project, the user has to first open the tool window. This will automatically open two windows. Once that is done, the scene has to be initialized. This will create a main map, a player for testing, as well as showing the custom inspector in the main window. Selecting the main map, the user can change settings within the custom inspector. In this case, it's changing the size of the map as well as the name. Building the scene again will rebuild the map, applying the new map size to it. The user is able to randomize the default ground tile visuals of the map by setting 3 arrays of sprites. Each of these arrays is given a weight. This weight determines their chance of being picked in the randomizer, which will then pick a random element within the array if chosen. Again, building will apply these changes. There's also the Builder tab with which the user can place new prefabs and paint terrain. In this case, we'll be placing a new submap. Clicking this button will show the settings that can be changed in the Builder Details window. This is similar to the custom inspector. Again, we'll be changing the map size, and as you can see, it will apply the changes as the submap is placed. We can once again set the tile visuals of the map. As an extra feature, we can just copy and paste the visuals from one map to another to save time. In the Builder tab, the user can paint terrain, and we'll start with some water terrain. The user can place the terrain in the map, change the size of the painter itself, as well as easily erase terrain where needed. In any map, the user can place prefabs and paint terrain, though the map first has to be selected. We will place some lava as well as some swamp in the submap, and add some roads to both of the maps, which also actually have the tile visual randomizer individually, although it's slightly hard to see in the video. Each of the tiles of the terrain will have some logic to them. Water and lava will swallow the player and NPCs, roads will increase the speed of the player and NPCs, and purple swamp will decrease the speed. Building the scene will apply these logics. Building net mesh for NPCs to walk on, as you can see, and if we enable debug, it will show the recover triggers that are built. These are the locations the player will respawn if they're swallowed by a terrain such as lava or water. Now we'll place some in-map teleporters. Using the builder details, we will link the next teleporter we will place with the one already placed. This will mirror the teleporters, teleporting the player from the first teleporter to the second and the other way around. We can also teleport between maps and link teleporters using the custom inspector. The tool will indicate with red if a variable has to be set in order for the object to work. And we can now select the other teleporter we want to teleport to and press the mirror button, which will link both teleporters together like we did before. Selecting a teleporter will auto-enable debug, showing where the player will be teleported towards. Enabling all debug will show all teleport locations from all teleporters. Next up are the level teleporters. These will load a new scene. You can set the settings in the builder details or custom inspector like always. The tool actually checks whether a scene exists and makes sure that it's not the same scene as the user is currently in. Next up we will place NPCs. First some enemies. The user can select an enemy type in the builder details or custom inspector. For this example we'll place one green melee enemy and 2 range enemies, each in one map. The user can also place friendly NPCs, with which the player can interact in-game. Debug is automatically enabled when we select the NPC, which will show the move zone of this NPC. This is the zone the NPC will patrol in, and there are 2 types of move zone styles, walking in a straight line or to a random position. We can directly select the move zone points, or use the tool to select them. Dragging the move zone points will increase or decrease the size of the zone. We can also change some movement zone settings, from how far the NPC will walk to how long it will wait between walks. Both values are randomized between a minimum and a maximum value. With any game object with the debug script we can change some setting. In this example we'll change the color. Instead of a move zone, the NPC can also use waypoints instead. The user can add new waypoints and move them around. The NPC will loop from waypoint 0 to the last and back again. Waypoints can be set on random. The NPC will then grab a random waypoint each time. However, it cannot grab a random waypoint it is currently on or was previously at. The user can delete waypoints, insert new waypoints, as well as being able to reorder them easily, as can be seen here. Debug will show the path the NPC moves between the waypoints, as well as showing the direction it will move to with the arrows. Zooming in will visualize the individual waypoint settings within the scene. A waypoint can have a wait time, which is the time an NPC will wait at a waypoint. The wait time is randomized between the minimum and maximum value given. Additionally, a look at direction can be set or randomized for each waypoint. Selecting a map will show a list of NPCs in that map, giving easy access to NPCs. Their debug visuals can be enabled and disabled, as well as having the editor camera move to its position and selecting the NPC using a button. Next up is the goal system. This system sets flags true or false on player action in the game. Flags can be saved or loaded by the game, and other systems like the cutscene and dialogue system use flags or are triggered by them. The goal system also handles level complete and game completion states. A goal can be added to any type of teleporter. These goals are then triggered if the teleporter is used. A name can also optionally be given to a goal, and the user can set whether the goal is a normal goal, level completion or game completion goal. Removing a goal is a destructive action. As for all destructive actions, a warning will pop up. A flag name needs to be given if the goal is a normal goal. This is the flag that will be set in-game. A goal can also be a switch. This will set a flag from false to true and the other way around. A flag that is set the same value as it already is will not trigger anything. The user can also place collision goals. Collision goals are triggers that set a flag if the player walks in them. Goal settings can, as any other setting, also be set before placing the object. The user can change the size of a trigger before and after placing it. And as you can see, the builder indicator will actually change size depending on the size of the trigger that will be placed. Triggers will only show if the debug is enabled. The user can also set the trigger to wireframe instead of a box and the other way around, additionally to normal debug settings. The user can find a list of all goals in the level if selecting any of the maps. It doesn't show specific in-map goals, as goals are generally not map specific. The name of the foldouts show information of the goal. Any errors will also show up, making them easier to spot. And the user can select, go to and enable debug of any goal. A defeat goal is a special kind of goal that can only be created when selecting any of the maps. New defeat goals can be added and removed within the custom inspector. The user can assign one or more enemy NPCs to a defeat goal. A flag is then set if all those NPCs are defeated within the game. As a side note, defeat goals do not exist as a component within the level like teleporter and collision goals do. The following is a walkthrough of the level I just created. The player is able to teleport and NPCs have attack behaviors and can hurt the player. If the player falls in lava, it will respawn at one of the auto-build recover triggers. If the player defeats this enemy, it will trigger the defeat goal I set up. While hard to spot in the video, a debug is printed in the console every time a flag is set. The player will walk slow on swamp and fast on the road. At walking into the level teleporter triggers the level complete goal, which is also printed in the console. The scene I set up in the level teleporter is loaded, and this concludes the walkthrough. Lastly, I want to show how new builder buttons and button categories can be made using the Unity inspector. A new category can be created by adding a new element to the following array, giving it a name, and adding elements to this new array creates new buttons. We will give the new button a name and a tooltip, which will both show up if we hover over the button. Now I will add a prefab and set its initial rotation it will have when placed. We can set it to be placed in, outside, or both in and outside of the map. We can then set the rotation type and on which axis it can be rotated. This decides if we can rotate the object before we place it or when we have it selected using the custom inspector. We can do the same with scale, but we leave it locked. As you can see, the demo category has been made and it has a button which has an auto-generated preview and a name and tooltip we set before. We can now place it in the map and it works as intended. that concludes this video. Thank you for watching.